स्वच्छ भारत का इरादा इरादा कर लिया हमने देश से अपने ये वादा कर लिया हमने।
एक पवित्र सी हवा बहेगी,
उज्ज्वल उज्ज्वल हो भारत,
कोना कोना निर्मल होगा,
विश्व कहेगा जय भारत।
जाग उठेंगे भाग्य हमारे, स्वच्छ बनेगा ये भारत।
स्वच्छ भारत का इरादा इरादा कर लिया हमने देश से अपने वादा कर लिया हमने, ये वादा कर लिया हमने, ये वादा कर लिया
What if the waste you throw out during the day lights up your street at night? It's possible. In fact, many streets in Pune are lit up every single night on garbage-based biogas. Each day, these biogas plants in Pune treat about 125 tons of organic waste and in the process produce energy and manure. Pune's 40 lakh population generates 1,600 to 1,700 tons of municipal solid waste daily, with an average of 400 grams of waste generated per person per day. Of the municipal solid waste produced in the city each day, about 45% to 50% is organic waste. Until June 2010, a major portion of this waste was being dumped at the 164-acre Devachi Urli landfill site, 22 kilometers away from the city. The landfill site exhausted its carrying capacity several years ago, but with limited options, the city continued to send its waste there. Having struggled with this problem for years, the Pune Municipal Corporation decided to set up decentralized bioenergy plants. Currently, there are 25 plants in the city, each treating up to 5 tons of organic waste per day and converting it to energy and manure. The power generated in these plants is used to operate street lights in Pune.
Direct benefit as well as indirect benefits are there. While selecting the technology, anyhow we have to consider the following points, that is sustainable technology, commercial viability, then the technology should be environment friendly and it should be socially acceptable.
Mailham Icos Environment Private Limited is one company converting organic waste into biogas. Their renewable energy device converts waste into renewable resource for generating power that can be used for day-to-day consumption. They currently have 5 to 10 tons per day biogas plants in 3 wards in the city of Pune.
The basic technology is modified upflow anaerobic sludge blanket. This is an anaerobic digestion technology which is used mostly for the wet organic waste, the stinking part of the municipal garbage. And we are working pan-India. Wherever you have vegetable waste, fruit market waste, slaughter, dairy, distillery, sugar, starch, anything that stinks, that is where we put up these biogas projects, generate biogas and also compost.
A major portion of the solid waste in Pune is collected from households through waste pickers in push carts, ghanta gadis or containerized trucks. The segregated waste is then taken to transfer stations, where it is weighed and then taken to processing plants. Here, the organic waste is further scanned and crushed into slurry. The slurry is then pumped into the digester tanks. Over a few days, biogas is produced, and then, with the help of generators, it is converted into electricity. A certain amount is also converted to compost. For the successful operation of these plants, residents are expected to segregate the waste at the household level. Close to 56% of the waste in Pune is currently segregated at source.
From the Melham systems, you will get three outputs. Number one is biogas, which can be used either as a cooking fuel or for power generation, or even for converting it to bio-CNG. The other output you get is liquid manure, which is what we call overflow, which again sells very well, can be easily sprayed onto your vermi pits or your composting heaps. The third output that you get is solid sludge from the bottom of the systems, which is directly used as a manure, as a good organic manure. We don't use any chemicals in this process. As a result, this is genuinely organic manure.
For a typical ward of 50,000 to 60,000 people, around 5 tons of organic waste is generated per day. So, a 5-ton biogas plant is almost perfect for a single ward. It can generate 300 cubic meters of biogas daily. This translates into 420 to 450 electrical units every day.
When you talk of 420 or 450 units per day, it lights up almost around 150 to 200 street lights depending on the wattage of the street lights. And this is for around 10 to 12 hours every day, actually every night.
The budgetary cost of 1 5 TPD biogas plant based on segregated organic waste for power generation as end use is 1 crore and 5 lakhs. For a 10 TPD biogas plant, it is 1 crore and 70 lakhs. The PMC came up with a detailed strategy to make this project a success. This included creation of awareness among citizens for segregation of wet and dry waste at source, and having their own biomethanization or composting stations at housing complex or ward level. A system was put in place to separately collect and transport wet waste from bulk waste producers like hotels, restaurants, markets, offices, etc. to the plants. NGOs and waste picker organizations were involved for door-to-door collection and primary transportation of wet waste. The PMC ensured that space was made available for setting up of biomethanization plants in all electoral wards.
Within the city, it is very difficult to have a big piece of land, space because of space constraint, and that's why anyhow we have to choose such a technology which requires less space. That is one thing. Then whatever water as well as electricity will be provided by PMC, because it's a government thing. That's why for initial stages, whatever electricity is required, that is provided by PMC, and water is provided by PMC, but at a reasonable rate.
To ensure these plants work well, the PMC has a lot of work, from collection and transportation of waste to supplying power and water. So what does the PMC do? The PMC supplies segregated organic waste at the project site free of cost. They also provide clear land area of about 500 to 600 square meters with proper approach roads. They also provide water and electricity connections at project site free of cost from time of construction to period of O&M. They help in obtaining necessary clearances, making arrangements to collect, take away and dispose of rejects, making necessary arrangements for security at the project site, and also ensuring electricity distribution arrangement from the biogas engine control panel to the user point. Since the commencement of these bioenergy plants, the Pune Municipal Corporation has been able to process and convert significant quantities of waste into energy and manure. Till October 2016, the PMC has achieved some remarkable results. For example, 11,500 tons of segregated organic waste has been processed in the plants. 5.75 lakh cubic meters of biogas has been produced at a daily average of 55 to 60 cubic meters. 1,85,000 kilowatts of electricity has been generated and 340 tons of manure produced. With the PMC actively working towards creating energy out of waste, other measures of waste management are also underway. A similar technology is being used to produce slightly different kind of fuel at the biogas CNG plant in Pune. Established as a public-private partnership between the Pune Municipal Corporation and Noble Exchange Environment Solutions, the plant was installed in 2016 in Talegaon. Commercial operations at the plant for processing 350 tons of food waste every day commenced in the second quarter of 2016. The bio-CNG fuel it produces is scheduled to begin commercial sales from January 2017. Located on a 20,000 square meter plot, the plant receives segregated food waste. It is screened for impurities and other inorganic materials and then crushed to convert it into liquid slurry. The slurry is then transported in closed tankers that are drip-free and odor-free. The tankers take the slurry to the central processing plant 30 kilometers away from the city. At present, the capacity utilization at the plant is 150 to 200 tons daily, and operations are being scaled up gradually. On an average, 18,000 kilograms of bio-CNG is produced at the plant. 1 kilogram of bio-CNG is successful to replace 2 liters HSD in automotive manufacturing operations. The average cost to set up the plant is Rs 65 crores.
Our specialization and focus is on the food waste. It's a highly complex medium to handle because the constituents or what contributes into the food waste streams keeps changing by the season, by location, by geography. So there's no fixed composition of the incoming waste, and that makes it fairly dynamic as a medium. In this facility, we segregate or we do what we call secondary screening of the food waste, which means to remove any balance impurities which may be there. Our team members in this location are really employed from street scavenging, unorganized sector. So there is a bit of an impact that we start creating from the word go. We bring these men and women out from the streets where they currently are working and bring them into formal employment.
Let's see what is the technology being used in this plant. The plant uses anaerobic digestion to process waste and generate biogas. The anaerobic digestion process uses microorganisms to break down biodegradable waste to produce biogas and organic manure. Biogas, when cleaned and purified to 95% purity, is called bio-CNG.
While we are able to do segregation, So, the food waste can be segregated from the other waste, and from the food waste, we are now being able to put up plants which will produce CNG or which will produce biogas, which actually run street lights or which run public transport, which is such a unique and creates wealth out of waste. Because you just collect mixed waste, then decentralized process of waste management will not work. So I think underlying philosophy has to be segregation of waste, resource recovery, and creation of wealth from waste. So the complete cycle has to be seen, and I think that is where we are focused.
The biomethanization project won the Maratha Chamber of Commerce, Industries and Agriculture Dr. R.J. Rathi Award for Environment Pollution Prevention 2010. Encouraged by the great success of the existing biogas plants, the municipal corporation plans another 15 bioenergy plants in Pune. The city is well on its way to maximizing green energy production with the waste it generates. It has set a great learning example for other corporations on how to treat waste as a resource and convert it into energy. Lighting up the city and streets of India every night. Indeed, it is showing India a waste to energy technology that is good for it.